Hello students, so this is Brock Skaggs. I'm going to make this video as a demonstration of some modeling concepts inside of SolidWorks. As usual, I've got a part that I'll be modeling that you can see in the drawing in front of me here. And so you got a default and a configuration A version of the part. See, the material down in the title block is 1020 steel. And our unit system is going to be MMGS here, so all the length units will be in millimeters. And so if we go to the second sheet, we should have the detail drawing for the default configuration. And so you can see the typical front, top, and right view. Notice the front view here is actually a section view with the cutting plane section lines in the top view there. We also have a detail B there showing the what would be kind of snap ring grooves that have been created inside of that inner cylindrical face. And so that'll be the initial goal. And then after we get that modeled, we'll want to make the finalized part, which is config A here. And so here we've made a few changes. You can see the interior cut, the snap rings are gone, and also it's not just a simple cut. Now we've got something where it goes down with one diameter, then transitions to a larger diameter there. Also very noticeably, kind of the tabs around the circumference of the part, or that base perimeter if you will, have moved from 4 instances to 8 instances. And we also have a few features on the top side as well here, which are new. And one other thing is I think the base feature actually is changing in height as well, from 20 to 25 units in length there. And so all those changes we'll hopefully be able to make when we get into SolidWorks here. And so with that being said, let's go ahead and hop right into SolidWorks and get this started. So I'm in SolidWorks at this point. We'll change the unit system to MMGS, and we said the material was AISI 1020 steel, and so we'll go ahead and apply that as well. And so now we're ready to get started. And so thinking about a little bit of strategy is how we're going to make this part, and then also thinking about the revisions that are going to be here. One thing I'm going to do is use the revolve feature. You can see there's quite a bit of axis symmetry happening here. So the revolve feature, the revolve cut come to mind. Also circular patterns as well here. And so one thing about the interior region of this part here, here you've got the hole with the snap ring grooves, and notice in the second version of the part, that's a totally different piece of geometry in here. And so the way I'm going to approach that is that I'll first go ahead and create a revolve feature in order to create most of the material. And then for the initial instance, I'm going to create a second revolve cut feature to create the hole in the snap ring grooves. And then that'll allow me to, when I go to configuration A, be able to suppress that revolve cut in order to put in the new geometry on the interior of the part there. As far as the patterning of the tabs going from 4 to 8, that should be fairly easy to do as long as I do a feature pattern is my preferred method as opposed to a sketch pattern. And another thing I'm going to try to do here is use a global variable. See here that the height is 20 in this one and 25 in the config A version here. I'm going to control that with a global variable, and then we'll just change the value of the global variable as we go through between the configurations. That'll be a little bit more of an advanced way to achieve that ability. So with that being said, let's go ahead and hop right into the part. And so here I'll get into the part. I'm first going to go ahead and create that global variable. And so I'll just go up to Tools, Equations, and then I'll create the variable here. And so global variables is the first section of this dialog box. We'll call it base height. And by default, it's going to go to 20. And so I'll just leave comments blank, and that should create a global variable. Notice here, after I've created it, I now have a folder called equations in my tree structure, and I can see the base height variable name and the current value of 20. As far as taking a moment to note the origin location, notice it's at the very bottom of the part here, and right in the middle of the part here that you can see from that section front view. And so for that, I'm going to get a sketch going on the front plane. This is going to be a revolve feature, so I'll go ahead and draw my center line here. That will be the axis of revolution. And I'm going to just draw very roughly the contour here of the part. And so just like that. And so now we should start applying the dimensions as usual. And so you can see the overall height of this is 100 units just like so. The overall, or not the overall diameter, but this first diameter is 125 millimeters, so I'll go ahead and utilize the center line here and of course pull across so I can measure the diameter instead of the radius. We've got a angle dimension here of 60, which is going to go here. And then we have that height dimension of 20. Now notice we tied that value to a global variable, so when I go to apply this dimension here, I don't just want to type in a hard value of 20, but I want to hit equals here so I can go down into the global variables. And so all I did was hit equals, and then I arrowed down into the global variables area, and then I can arrow to the right to actually select the base height 20. And so you can see the notation it gives you inside of SolidWorks. That little sigma in red means that, hey, this thing either has a global variable in it or some sort of mathematical expression. So it could be tied to other dimensioned variables or other items there. But it's just giving you some notes, hey, this is not a hard value. It's got some special things going on. And so now we've got an overall diameter that we're searching for in the part. Right here from the top view, 200 millimeters. So I'll just drag it down here, make sure I've got the diameter, and I've arrived at my fully defined sketch. Now I'll just go ahead and revolve it as usual. So go straight into revolve boss and base, and it creates most of my material for me. So next step, we'll create the revolve cut inside of the material. And so I'll just get right back on the front plane to make my sketch. Control A to go normal 2. Here I'll go ahead and go to this view so I can see a little bit easier. And again, create my center line. I like to draw it down here because I know all my line segments are going to be up and above. And you can kind of see what the geometry looks like. I'm just going to draw the right half of this section of the front view. And so what I'll have here is just a vertical line. I go out here a ways. I come over, make my first notch, groove, make my second notch for the groove, and then come straight on down and close off the sketch here. And so before I get to apply dimensions, I'm going to add some relations to these groove notches. And so one thing I do know is that these two lines need to be collinear. Those two lines also need to be equal. And so now I've got this type of geometry happening. So in the detail view, I believe I've got a few dimensions for that. And so if I zoom back out on the PDF, go to the top right, is where my detail is. You can see the dimensions associated with it. And so it starts 10 millimeters above the top surface. And so this is my 10 millimeters here. They have 5 millimeters from that inner wall is the depth, if you will. Here, before I keep going any farther, I'm going to make sure that these two lines, actually these three lines here, all need to be collinear to bring those in line. The thickness of each one of these is 3 millimeters, which I've got the one dimension and the equals relation there. And then the spacing in between them is 5 millimeters. And so that should suffice for that geometry. So for the other dimensions, for my section view, I can see that inner cylindrical face is a diameter of 100 millimeters. And that fully defines our sketch for us. And so very quickly we have the sketch for the revolve cut feature. So quite intensive a little bit inside of that small area for the snap ring groove area, and then the overall diameter here. And so now we're ready to go from the sketch straight into a revolve cut feature. So you can kind of see the preview it's getting us, and we can accept it at this point. So I'll go ahead and turn shading back on, and you can see we're heading in the right directions. It's a good idea to always go back and check the ISO every once in a while, make sure you're going in the right direction there. As far as the next step, let's go ahead and create one of the tabs, and then we can pattern it around. And so notice the tab here, if this is the top view, it's not right in line with the origin as far as horizontal here, but it's been rotated by 45 degrees. And so we'll have to take note of that to make sure they're placed correctly. And so to make that, I'll first go right into the top plane and hit the sketch icon. I'll go normal to the sketch. First thing I'll do is create this kind of bolt circle. It's a 250 millimeter diameter circle, and you'll notice it'll be construction geometry. And so here, right mouse string over to the circle. There's the circle. It's centered at the origin and has a diameter of 250 millimeters. And then to turn it to construction, just click on the circle and go to construction geometry right here from that quick access box. And so now let's put in a couple of lines for construction to define that angle. And so what I'll do is I'll just draw one line strictly vertical, one line inclined to it. Both these will also be construction. And then I'll define the angle at 45 degrees. Now for the tab geometry. Here I'm going to leave off the rounds here. You can see from the note that there are 12s. Then I'll just create the other portion of it. And so there's the larger circle there. And it's got a couple lines coming off of it. And so here you can see they're coincident, but I also want to make sure that they are parallel with that construction line. So adding those relations now. Also, I need to make sure they're tangent. So this guy on the right side is not tangent, so I'll go ahead and add in the tangency relationship there. So you can see it update there for us. I don't really need the bottom half of the circle, so I'm trimming it out. And the large radius is 15 millimeters there. And so I'll go ahead and apply that 15 millimeter dimension. At this point, notice the left-hand side is not right. It looks like I missed the tangency there. And so I'll go ahead and apply that at this point. We can also go ahead and put the hole in here. The hole is a 12 millimeter diameter hole. And so I'll just putting it in there very easily there. It is concentric with the arc. And we're almost there. We just need to close off our sketch. You can see there's an opening right here for our sketch area to define the boss extrude. And so I'll go to convert entities, select this outer circular edge, and so that draws the circle, and then I'll go ahead and trim out what I don't need. So I trimmed here, so it removed everything here, but there's still a little bit of line segment right there. If you rotate, hopefully you can see that in the video, that there's a line segment there, so I need to trim out that part there, just leaving this little arc length, which is what I want. So that's looking okay. Nice fully defined sketch. And so I'll go exit the sketch, and while it's still selected, go straight into Extrude Boss and Base. And so here I want to link this height that I would extrude it to. Right now it's just 20, but it's going to be tied to that global variable base height. And so what I'll do, instead of entering a hard value here into the blind text box here, I'll just hit equals. I can go down to global variables again, and then I can reference the base height dimension. And so that should get me going. And so clicking OK, I have a message here. The sketch has both open and closed contours. Pick a specific entity. And so let's go ahead and investigate that and see if we can find anything. And so here I'm getting right back in the sketch. It says I have open and closed contours. One of the first things I usually do at this point is I check with my tools, sketch tools, repair sketch, and see if I can find anything here. And so right there, notice I found a small little arc segment. And if we zoom in on there, you can see that it's kind of overlapping here. This is the issue that it's talking about. And so that's the issue we're having inside of the sketch. And it appears I don't really need this part of the line segment here. I just want it to be from here and go on up. And so what I'll do is I'll go ahead and trim. And while I still have the magnifying glass option open, I'm going to trim just till I hit that little segment of line. And so now notice as I hit that little segment of line, it removed it. We're still fully defined, so let's give it another try. And so I'll go ahead and exit the sketch, select the sketch, go straight in, and notice this time it immediately generates the preview. So I believe we're in good shape. So again, I'll hit equals here, use my global variable height base to define the height of that extrusion, and then hit the green check mark in order to complete it. And so a little bit of troubleshooting we had to do there in order to get to our final piece of geometry. As far as the rounds, there are 12. Let's go ahead and add those as feature fillets. So just going to the simple fillet type, putting it 12 as the radius and selecting those two edges in order to define it. So now that I have that, we're ready to actually pattern it. And so right under the linear pattern is of course circular pattern. First I'll work from the top down. My pattern axis, I'll select this outer face to define it. And so it's picking up the center, or the temporary axis associated with that cylindrical face. The features to pattern, I'll just select from the graphics area. I want both the boss extrude as well as the fillet one there. It's already got 4 of them equally spaced, which is exactly what I'm looking for there. And so that creates the pattern, as you can see. And so taking a quick check of the drawing and of the isometric view here on the left hand side, and I believe we've arrived at that. And so I've got a couple of mass properties written down. We'll see if they match up. The mass 8,604.24 grams is good. The center mass at 0, 28.52 and 0. Excuse me. 0, 28.52 and 0 also looks good there. And so it looks like we're in good shape here. And so next we're on to trying to get configuration A here. And so I'll use configurations just to combine this in the same part. And so I'll just right click on the top node in the configurations tab. I'll go to add a configuration. And I'll just type in configuration A here. And so with that, let's go ahead and go to configuration A and see what needs changed. One thing I need to change is the value of that global variable, right? That was 20, now it's 25. That's tied to the base height global variable. And so let's go ahead and do that first and see if we can get that going. And so what I'll do is I'm just going to come over here to the equations. I'll right click and go manage equation. And notice here in the combo box here, I've on config A. Notice I can now go between config A and default. And so here, I'll go ahead and click this value. I'll make it 25, but then I'm going to come over here and say only apply it to this configuration and hit enter. And so I'll hit OK at this point, and I'll leave this open. So now we're in config A. You can see config A from the top notation here from the tree. Base height is 25. And so let's switch back immediately to default and check the value. Now base height is 20. And so what we have happening here is we're altering the value of the global variable between the configurations. And so you have 20 in the default and 25 in the config A. And also you can see the height, actual in the geometry, changing as well there. If you check that as we go through those configurations. And so we're in good shape there. Now let's go for the interior parts here. And so we need to suppress that first cut revolve one that had the hole and the snap ring grooves. And so what I'll do is I'll right click on it, I'll go configure feature, and then I will suppress it in configuration A. So here it's active in the default and suppressed in config A. And so that gives me a solid interior to make my revolve cut. And so I should be able to key in on the top right here in the section view in order to get the geometry for my sketch. And so here, very similar to our first revolve cut, I'll just go to the front plane and create a sketch. And I'll go normal too. Here I'm going to go ahead and show the hidden lines so that'll be a little easier to see where this boundary is at and all the other edges. And so again, as usual, I'll create my center line first. And then I'll start actually creating the geometry itself here. And so here, I'll apply my vertical line here. Then we'll come over off to the right. The geometry is going to look something like this. We'll have it go over to the right of ways. It's going to hit this line. It's going to come back over here. It'll hit this edge here, and then it'll go vertically downward. That should be roughly the way it shows in this drawing. Notice this line and this line are completely horizontal, and this point are also horizontal there. One other thing you'd have to pick up from the geometry is that this line segment here and the interior line segment here are parallel to each other. And so that'll be a geometric relation that we apply inside of the sketcher. And so I can hold control, get the line on the outside selected, the line on the inside selected, and we'll go to parallel there. And now you can see this thing slide left and right. As far as the overall diameter here at the top section is 100 millimeters. And so what I can do is select the line, select the center line, pull across to measure the diameter, and I have my 100 millimeter diameter there. At this point we're still underdefined, and you can see there's just a little bitty line segment here. So we need to get rid of it to make it fully defined. We're still not fully defined. It looks like I have another little bitty line segment up here. This is just something you have to watch out for to make sure that your sketches get fully defined. Here, as you use SolidWorks, you get to where you kind of look for those type of things. If you're just now learning the software, it may take a little bit longer for you to define those things. That's where that tools, sketch tools, repair sketch here can come in handy to find those little kind of baby lines that you didn't really mean to draw. But with that, we've got that nice fully defined sketch. We should be able to go straight into revolve cut, accept the 360-degree rotation, and create that initial geometry. So you can see now we've got the interior of the part hollowed out, if you will. So next we kind of have a little bit of a lid on top of it. If you kind of go to the front view, you can see we've got this covering, if you will, with a smaller hole. And so we should be able to determine that. It looks like that smaller hole is 85 millimeters in diameter, and you can see the thickness from the section view is 5 millimeters. And so what I'll do is I'll just create a sketch on the top face. Go normal 2. I'll first convert entities to get the outside circle, and then I'll just go ahead and draw a circle on the inside and dimension it to the 85 millimeters there. And so now when I extrude downward, I'm not going to be changing the overall height of the part, but I can go straight down, so just flipping it here in order to create that top geometry. So now you can see I've got this lip at the very top there. So what next? We've got the top features. And so here, you can notice this plane here is 70 units off from the axis of the part, that planar face. And so the way I'm going to achieve that is with reference geometry. And so I'll go reference geometry plane. What I'll do is select the right plane. And so you can see you can offset it from it, and I will offset it the 70 millimeters. What this allows me to do is have a sketch plane that I can draw on, and I'll extrude back in toward the part in order to connect everything together. And so I'm going to get on plane 1, hit sketch, go normal 2. And you can see it's a fairly simple sketch. As far as the boss extrude is just going to be the rectangle, and then I'll go with a cut extrude to create the hole. And so here at the rectangle first, I'll just draw the rectangle. I'll have that top edge in line with the top of the part. To center it, I'm going to draw a line connecting the midpoint of that line associated with the rectangle to the origin and make it vertical. And then I can change it to construction geometry. And then you can see the rectangle dimensions are 60 by 34. And so just quickly making 60 here and 34 off to the side. So that fully defines the sketch. And then I should be able to go straight into boss extrude. Here I'll flip it so I'm going back toward the geometry of the part. Instead of putting a blind value in here, I'm going to go up to next. So that way it goes right up until it contacts that cylindrical face. And so accepting that gets me started. And so now we need a hole through here. You can see from the top view, for instance, that the hole does go through all until it intersects that interior of the part. And the diameter of the hole is 20, and it's centered, as you can see, from the 30 and 17 dimensions. And so I'll go ahead and hit the sketch icon here, create a sketch on this face. One thing I'm going to do, instead of putting that 17 and 30 dimension in here, I'm just going to draw a line connecting diagonal corners. I'll make it construction, and then the center should be right at the midpoint of that line. And so that's a very quick way to center this circular hole. And the diameter is 20 there. So there's a quick and easy sketch in order to get to where I can go through a extrude cut here, just pulling it right into the extrude cut, and I'll still go up to next until it stops at this cylindrical face. And if I hit accept, you can see the hole being generated there. And so at this point I can hide the plane 1 for me. So one thing I need to do here is pattern it. I just basically need to pattern it 90 degrees so it's in this front area as well. And so what I'll do is I'll go back to circular pattern. I'll select the same face I did before to define the axis to pattern about. The features, I can click right from the tree. It's going to be the Boss Extrude 3 and the Cut Extrude 1, the last two sets here. But notice by default, I'm only going to put in 4 here if I accept the defaults here, 360 degrees and 4. I could manipulate this a little bit if I wanted to, but what I'm going to do is go down just to instances to skip. I'll click in here, make sure it's active, and what I can do is click these little purple or pink dots and tell it, hey, skip instance 3 and skip instance 2 here. And so that way I have just this instance here and the other instance that I'm desiring. And so that's one quick way in order to create that second instance there. As I rotate it around, it looks like it's behaving correctly. And so I think at this point we're very close. We just need to increase the number of instances of these tabs on the bottom. You can see the patterns have been modified to include 8 instances here instead of the 4. And so what I can do there, since I'm using configurations, is I should be able to right click on the circular pattern, go to configure feature. By default it's going to say suppress or unsuppress, but if I click this down arrow next to it and select D1, notice I get the number of instances here. And so here I just changed the 4 to an 8 for config A. And now when I hit OK, it should create the 8 different foots there, feet if you will, or tabs. So I've got 1, 2, 3, 4, 5, 6, 7, 8. And so that's looking good at this point. Go to, oops, go to isometric there and we can check from the original cover sheet and it looks like it is in good shape. One other check would be to check the mass properties. And I have 6271.92 grams is good. And then the center mass location 1.18, 37.82, and 1.18 there. And so it looks like we've arrived at the correct center mass location as well as the mass of the part there. And so that should complete this video. And so hopefully it helps you master some of the SolidWorks modeling concepts here and make you a better user of SolidWorks. Thank you for watching the video.